Okay, good. Thank you. So now we have all the panelists with us. And well, first of all, I would like to ask you to introduce yourself so we can go with the order of the slides. So we would start with Kawashima-san, please.
Hi, everybody. My name is Masa Kawashima. I work for NTT, leading IOWN's NTT's IOWN technology development. And at IOWN Global Forum, I'm serving as the chair of the technology working group.
Hi. Thank you, Kawashima. Okay, this works. So my name is Lieven. I am employed by Nokia. Very happy to be here. I am doing strategy for the network infrastructure and the optical automation. And in the forum, I'm actually the vice chair for the technical steering committee, the TSC. Thank you.
Thank you, Lieven. Mitsu-san.
Hello, everyone. Good morning. Yeah, this is Minsu from SK Telecom, who is responsible for the 6G R&D team at the company. I'm leading the entire 6G R&D team at SK Telecom, as well as I'm actively engaged in the IOWN Global Forum, especially in the INMTF part. Nice to meet you.
Thank you. Clara, please.
Hi, everybody. I'm Clara Lee. I work for Intel as a senior principal engineer on wireless standards. And I'm responsible for technology development for 6G and the standardization. In IOWN Global Forum, I work as the technology steering committee chair. Yes. Okay.
Thank you, Clara. So with that, we're going to kick off the panel. And I hope I can get back control on the clicker, on the slides. Okay, so we would like to start, Kawashima-san. We've been talking a lot about, IOWN, basically focusing on optical networks. So what are your thoughts on the evolution of optical networks?
IOWN APN stands for All Photonics Network. It's a new type of optical transport infrastructure. The base technology of Open APN is DWDM ROADM, which has long been used in carriers' backbone. But Open APN disaggregates ROADM into 3 tiers: spine, leaf, and transceivers, and distribute components to points closer to user's environment so that it can directly connect user sites with optical transport. We couldn't not do this in the past because optical transceivers are rack-scale systems. But today, thanks to the evolution of optical transceiver technologies, optical transceivers is just as big as a finger. So we can make this happen today. So OpenAPN is a good example of IOWN Global Forum's activity to leverage the evolution of device technologies and redefine our computing and network infrastructure.
Thank you, Kawashima-san. So this is interesting. Since we are in the Mobile World Congress, Lieven, how do you see this evolution of optical networks applicable to mobile networks, actually?
Good question. So if you would go to the next slide. Absolutely. What we see here, and we're in a mobile conference, so we need to talk a little bit about mobile. So we see that there are new services coming up, and I know we've had this discussion about new. The thing is that it's new, but it's bigger and faster. So we talk about the new immersive AR and VR that will generate a lot of traffic. The volumetric video, it says it itself, lots of traffic. Digital twins, the AI as well, that will generate a lot of traffic. We need to be able, new services, we need to be able to deal with that. And you can see on the left that 5G was already a big, huge step forwards from the 4G. Now we go to the 6G, guess what? A bigger step forward. What do we need to do? Well, we need to revisit our networks, hence IOWN. We need to look at new network capabilities. Everything, if it is bigger, we need to make sure that the carrier is bigger. So we need to make sure that we can deal with these new services. So we need to have sustainability is another one, excuse me. Sustainability is another aspect that is being added to the mix. So we need to be faster, bigger, at a reduced energetic cost. So all these things, the new capabilities, as you can see on the right, this is what we really need to work on. And we put that very serious in IOWN, and we work on that one very methodically. That's it.
Okay, thank you. So yeah, we talk about the evolution of optical networks, how basically they can be applicable and applied to mobile networks. You work for a network operator. What are the benefits you are expecting from this integration?
Okay, can you move to the next slide from my side? I don't think this is my slide. Next one. Okay, yeah, right. Yeah, go back. Just go back. Oh, next slide. Okay, yeah. So yeah. What I'm here is, so I'm belonging to the mobile operator. So mobile operator network, we have the three major part of the transport network. One is the backbone network, another is backhaul network, and the special part is the fronthaul network, which is very important part for Cloud RAN operator. Yeah, let me briefly explain the Cloud RAN. Cloud RAN architecture is the baseband part is concentrated on the DU hotel, and multiple RU is connected to the DU hotel. So that the transport between DU and RU is very important because the number of fronthaul is very large scale, and so the importance of fronthaul in terms of energy efficiency and the cost efficiency is very important part. Next slide part. And from that perspective, so APN is one of the crucial component to save the energy and to save the cost money. Yeah, that's it.
Okay, thank you very much. You both touched about energy consumption and sustainability. Lieven was talking about that. Next I would like to ask you, Lieven, what are your thoughts on energy efficiency? But before, you want to cover the slides you didn't cover?
Yes, I think it makes sense to take one step back.
Yeah, exactly.
If you go back one more time. So we've talked about the requirements. We looked at an example already. If we go to the next slide. If you look at the APN and IOWN reference architecture, it's applicable to the front haul, mid haul, and the back haul. So it's important, what we thought, is to give things a name. So we have the APNT, all-photonic transceiver, APNG, gateway, I interchain, and the controller. You can see that on the right. So these functional architectural blocks are applicable to any network architecture. What we've done in our work is actually we looked and applied these architectural reference to a front haul. And you can see, for example, on the right, how that could be. Now, as we know, there are different deployments that can be applied to a front haul. We've also studied that. If you go to the next slide, you can see, for example, we have an all-photonic, a passive network, passive at the cell side and passive at the aggregation side. And then you have a full active, where you have an APNG on both sides with potentially an APN in the middle. So these architectures we've studied in terms of total cost of ownership. We've looked at the energy efficiency. So we've looked at that, and then for operators to guide them to make a choice, what is the best for their needs, that we can help them make a decision on that. So if we then go to the next slide, then we've talked about this. Now, if we then think about the energy efficiency. Energy efficiency for us is in the same parameter as elastic networking. And elastic networking, we've already talked about that a long time. But if you look, for example, on the idea is basically to shut down resources that are not used or put them in a hibernated state. We can do that on all kinds of things, on radios, on DUs, on CUs, but we can also do that on the network. And we wanted to see what the impact is if we do that. The driver is actually, if you look at the number of UEs connected in certain urban or rural areas, you can see that there is this huge bathtub curve. During the night, obviously, the number of UEs connected to the network, the mobile network, is a whole lot less. NTT provided us with the data. It can scale up to 10 times less in an urban network versus in a rural network 5 times. We know that that will always be there, meaning the day and night curves will always be there. So the intent is then, well, if we look on the right side, if you look on the top during the day, a lot of UEs connected, the number of DUs and the resources to be able to provide mobile connectivity and communications is at its max. So we pull the full load on. You can see the arrow going to 100%. On the other hand, during the night, these resources, they spin there, they waste energy for nothing, because there is no UE, or the number of UEs drop. So the intent is to shut down and relocate, if possible, some DU mobile controllers like virtual DUs. There is a twofold aspect with that. The first one is the RUs need to be capable of connecting to a DU pool. That's the mobile control plane aspect. The second aspect is that your network needs to be able to communicate and reconfigure those DUs because the association will need to change, RU-DU association. We have done actually a first step in a proof of concept there. If you go to the next step, so by the way, I forgot to say, it's obviously if you don't use the resources, you shut them down, you gain energy. Now, what we've done, and I really like the methodology that we applied, in IOWN, we've done a reference proof of concept document where we said what we were going to test with check marks on the side. Then we have a reference architecture. From there on, with check marks. From there on, we went into the lab, and we did that jointly together with NTT. We went into the lab, shipped our equipment, made it all up and running, and we checked marked, and we have the KPIs documented in a document on the right. Now, of course, while we were doing that, we learned a few things, and that feedback will go back into the POC reference, so we make our tests more and more accurate. I want to say that we have also a press release that we launched, I think, 2 or 3 weeks ago, where we actually acclaimed this and made it public on what we have achieved. I really believe in this, and if you have more interest to come and participate with this, please reach out. If you go to the next slide. Thank you.
Yeah. Thank you, Lieven. So this is really interesting, and again, I agree. I mean, talking to people during the week, everybody was very excited about the fact that, you know, sustainability and energy efficiency, they are important goals of IOWN, and how can you power down parts of the network? It may be a DU, it may be an RU, and basically be adapting to the circumstances. Just for completeness, before we go with Clara, another use case that people are very excited about is the sharing of a RAN network. So we've been talking about, you know, the basically CapEx you will need when deploying the next network, maybe 6G, for example. So the fact that these technologies will let you share the same virtual radio network among several operators, that's also a huge advantage, and people are paying a lot of attention to that. So those main use cases, I agree, it's really important to keep them in mind, because if you think of, you know, the next steps of IOWN Global Forum, what we are working on right now, those I would say they summarize very well, at least when it comes to mobile networks. Again, we are working on other use cases, but for mobile networks, it's extremely important. And thanks also from the operator's perspective on what would be the benefit. But with that said, as I said before as well, this is about optical transport, but not only that. So what do you need to change in upper layers in order to basically take advantage of these new technologies? And that's why I would like to hear Clara talk about another of the basically key components of IOWN Global Network, the DCI. So please, Clara.
Yeah, sure. So IOWN DCI stands for data-centric infrastructure. So the design goal is to enable communication computing infrastructure for moving and processing data and meeting extreme performance requirements in terms of the throughput, latency, jitter, and also achieve high energy efficiency and also resource utilization efficiency. So there are a few key enablers for IOWN DCI. The first enabler is the disaggregated and heterogeneous computing, which we could create a bigger pool of computing resources and has the flexibility to choose the right amount of computing resources for the workload. Another key enabler is the dynamic logical service node formation, such that we could form logical computing service nodes on demand, based on the workload demand, and out of computing resources across different physical nodes. And third enabler is the inter-data center RDMA or APN. So this is really enabled by the photonics network that IOWN has been developing, such that we could enable remote direct memory access between different data centers for optimized data access across data centers. So a fourth enabler is accelerator sharing and pooling, not only within data centers, but also across data centers. So this is important that we, by using this technology, we can optimize the placement of the computing resources and look from the global scale to optimize that. Not only in local scale, but also optimize the computing resource placement from a global scale. So overall, we say DCI could be infrastructure to host the future data centers as well as mobile network workloads. And also, as just previous speaker discussed, this is also the fundamental architecture we say could empower computing resource sharing and enable the energy consumption reduction. Yeah.
Maybe can I jump in? Yeah, I believe DCI would be a good computing platform to build an elastic virtual RAN system. In addition, I'd like to highlight that DCI will transform edge computing infrastructure. With DCI and APN, we can achieve edge cloud convergence, which means we can allow multiple edge computing infrastructures to share a large pool of computing resources of cloud over APN. I guess today, many telcos are now struggling with the low return on investment of edge computing infrastructures because edge computing inherently lowers the IT utilization rate. On the other hand, if we use APN, we can improve the ROI of MEC by creating a large computing resource pool on the cloud. I expect this concept, edge cloud convergence, will be of strong interest to many telcos in near future.
Absolutely. Thank you. We've been talking about the way IOWN Global Forum works, and I think this illustrates quite well. And I like leaving your slide explaining how basically going into the proof of concept prototypes, they help us refine actually technical specifications, the way we benchmark actually when we are doing the POCs, as we call them, and then how eventually we will end up in early deployments, because at the end of the day, that's kind of the next major goal, getting to early commercial deployments. So Kawashima-san, why don't you introduce us to what we call from vision to reality and those early adopter commercial deployments?
So in addition to an effort to realize the radio optical convergence we just discussed today, we have just started a new effort to create IOWN's early adoption use cases. And a lot of members are now participating in this effort under a slogan, vision to reality. For example, we are now developing a reference design for IOWN-based IT tech infrastructures for financial services, which should allow banks to build a transaction database with multi-DC redundancy. And another use case we are developing is a media transport over APN, which should allow broadcast stations to stream a high-definition media from event spots like football stadium to video broadcast stations. And the last one, which I think is most interesting to you, is IOWN-based AI DevOps infrastructure. Now AI has become the center of competition in many industries. But many enterprises are now struggling to find data centers to deploy power-hungry AI servers. So if we use APN, we will be able to connect enterprises' product development sites with suburban data centers or rural data centers, which would be an ideal place to deploy power-hungry AI servers. So in summary, IOWN-based network and compute infrastructure will help people reduce the IT CapEx and OpEx while accelerating the digital transformation of their businesses. So we will demonstrate such benefits in 3 specific areas: financial service, video broadcast, and AI. So please stay tuned for updates from IOWN Global Forum.
Thank you, Kawashima-san. Maybe because we've been mentioning, of course, the use cases most relevant to basically a telco network, and you mentioned the financial basically. And usually when we've been talking to people, that kind of, triggers a lot of attention. Maybe can you spend a minute explaining the work on replicating databases and the challenges we saw there?
Okay, so in order to replicate, for example, transaction database, we need a data center interconnection which can achieve latency lower than a few milliseconds. And it's very difficult to find such connection solution today. But if we use IOWN APN, we can satisfy such requirements. So that would help many banks to build highly reliable transaction systems.
Excellent. Thank you. I think that's useful. So if I can summarize a bit, as you see, I mean, IOWN is working on several layers, and as we said, end-to-end on several axes. So it's difficult to grasp, the whole, basically, landscape. So we hope that we have given you a bit of where we are working. We thought that, this kind of, especially at the Mobile World Congress, these topics would be of your interest. So to summarize a bit, many companies involved. We saw the executive panel. It's really exciting to see companies basically being member. We are growing in membership by the minute. And then the ways of working, which I think is the basic competitive advantage of IOWN Global Forum. End-to-end, having companies, and not. By the way, I'm talking about companies, but we also have academia, which is very good. As Kawasoe-san was referring to before, we try to be innovative and getting these academics bring their own research ideas into the forum. That's also one of the key parts of our ways of working. So that's extremely important. Something we were asked as well. It's how to get involved or how to learn more. So we were basically leaving there QR codes where you can go to our webpage and basically read about the white papers. You may want to start with the vision white paper. That's aspirational. That's very long term. So, but it's good to understand where we want to go. And Kawasoe-san was basically showing a couple of use cases where you see, to your point, how IOWN Global Forum is not only about technology, but it's also about being a force for good in society and changing lives for the better. So that will give you an idea of where we want to go. Apart from our guiding star, which is the vision paper, I encourage you to read other white papers that explain the technologies, so you can have a deep dive on the APN or the DCI or any other technologies. Also look into the requirements, because looking into use cases, that's quite exciting. Maybe you are coming from a different industry and you wonder what IOWN could do for you, so that's excellent. So those would be the natural next steps for you to basically get connected to the IOWN Global Forum. If you are even more interested, we basically are starting having open sessions in our member meetings. We have several member meetings across the world every year, and we call them futures sessions, because we usually have interesting keynotes so that they explain what's happening in different technology fields, or again, use cases. Sometimes we have researchers, professors explaining their own research. So I think that could be exciting. You could also see the vibe of the basically meeting, how the members are interacting, what you could get out of it. So if you are interested, it's also possible from the webpage to check that. Our next meeting will be in Vancouver, Canada, in April. So that would be a great opportunity if you are close by to stop by and basically check the session. Other than that, you can, of course, become a member. It's also available on the webpage, and then you can basically be part of all these discussions and this community we are building, and is growing by the minute. And with that, I would like to thank the technology panelists as well. I thank the executive panelists as well. And again, the call for action, please reach out if you have any questions. Consider attending the Futures event. Consider becoming a member, and help us basically support making the vision of the IOWN Global Forum reality.